Hello friends, today I am going to do the problem on the topics of the cables of analysis of structure, BTech engineering. So here the question is telling that a light cable, a light cable is supported at 2 points 20 meter apart. Means the light cable means there is a no weight of the cable, a weightless cable you can say. It's supported at 2 points 20 meter apart. Means 2 points means let us take the points A and point B, which is 20 meter apart. The question is telling that 20 meter apart, which are at the same level. Same level means there is no difference of the level between the A and B, which are at the same level. We can see the cable support three concentrated load as shown in the figure. The question is telling that there is a three concentrated load, means there is a pointed load, three pointed load, which is supported by the cables. The first load is given 40 kilonewton, which is 5 meter from the support A, and 30 kilonewton, which is again 5 meter from this point, and as shown in the figure, this is 20 kilonewton, which is 5 meter from the support B. Now the question is telling to find the question is telling that the deflection at the first point is found to be 0.8 meter. Yes, the question is telling that the deflection at first point is found to be 0.8 meter. The question is telling that the value of the y1 deflection means the uh, the value of the y, which is first point is found to be 0.8 meter. The value of the y1 is given 0.8 meter. Determine the tension in the different segments. Determine the tension in the different segment means we have to find the tension in this rope, in this cable, we can say, and in this cable, and in this cable, and also in this cable. Let us take this point as a C, and this point as a D, and this point as a E. Now we are going to start this problem. Now first of all we are going to find the vertical reaction, that is VA and VB. So if we will take the moment about A equal to 0, which will be equal to 0, we automatically get the vertical force VB. So let us start to do the problem. Now take moment about A equal to 0, take clockwise positive, anti-clockwise negative. Now moment about A equal to 0 means 0 equal to how much load is creating the moment about A. This VB force is creating the moment which is 20 meter from the A. So here we have to write, and it is rotating anti-clockwise. So VB into 20, anti-clockwise means we take negative, and this 20 kilonewton is clockwise. This force is clockwise, which is downward acting, and which is 15 meter apart from the point A, which is giving the moment to the point A. So plus 20 into 15, and again this 30 kilonewton. Similarly 30 into the distance will be now 10, again plus 40 into the distance will be 5. Now we got the VB on calci. On solving on calci we got 20 into 15 plus 30 into 10 plus 40 into 5. If you will divide by 20, we got 40 kilonewton. We got 40 kilonewton VV. Now the summation of vertical force will be equal to 0. Upward we take positive, downward negative. VA plus VB equal to VA plus VB minus 40 minus 30 minus 20, which will be equal to 0. Here we got VA plus VB equal to 40 plus 30 plus 20 will be equal to 90. 40 plus 30 plus 20 will be equal to 90. Now we already got the VB. We substitute the value of the VB and we get the VA. VA equal to 90 minus 40. 90 minus 40 will be equal to VA equal to 50 kilonewton. Now we got VA and VB. Now we have to find the horizontal reaction. For horizontal reaction, we take the moment about C. Now we take moment, as you know that this is a cable. The cable will have cable will not take the any moment. So moment about C will be equal to 0. 0 equal to VA. As we see here, VA is rotating clockwise and H is giving anti-clockwise. So here we can see VA about C. C is the stationary point and V is the vertical reaction, which is perpendicular distance between VA and about C is VA about C is 5 meter. So VA into 5. Now H force. H is giving anti-clockwise, so minus H into the Y1. Y1 is already given us that Y1 equal to 0.8 meter. It is already given in the question. 0.8 meter. So H into Y1. Now VA we already got in the upwards. 0 equal to 50 into 5 minus H into 0.8. Now we got H equal to 50 into 5 divided by 0.8. We will got 312.5. 312.5 is the horizontal. 312.5 kilonewton. In question it is given theta 1, here it is given theta 2, and here it is given theta 3, and it is given here theta 4. Now we have to find the value of the Y2 and Y3. Here we are going to find the value of the Y2 and Y3. For that we take the moment about D equal to 0. If you will take the moment about D equal to 0, we got the value of the Y2. We will get the value of the Y2. If you will take the moment about E equal to 0, we will get the value of the Y3. Let's see, I am doing in the papers. Now moment about D equal to 0. Let's see in the figure. D, as we take either we can go on left side, or we can go in the right side. So we are going to the left side for solving this. So let's see, the horizontal force will be same due to no extra horizontal force is acting. So the HA equal to HB equal to 312.5 kilonewton. That we have to understand. Now I am going to take the moment about D equal to 0. Let's see here, moment about D equal to 0. So moment about D equal to 0. Let's see, the vertical VA is giving anti-clockwise or clockwise. It is giving the clockwise rotation, and the distance of this D up to E is perpendicular distance is 10 meter. So we take 10 meter, and there is more horizontal. H is also acting here. HA we can take here it as a now minus HA is anticlockwise, HA into y2. The force direction is this like, and the perpendicular distance between the D and this force is y2, so we have to take the y2. Now the extra force, this 40 kilonewton, is also acting here. So the 40 kilonewton is the distance of 5 meter from the point D. So the 40 kilonewton is tried to rotate in the anti-clockwise direction. So we take it as a minus 40 into 5. Now VA already we got, VA and HA. Only the unknown will be the Y2 we can get. So VA 50 into 10 minus HA 312.5 into Y2 minus 40 into 5. Now let's see here on doing on calci. We take this as the right side and remaining to as it is, means 50 into 10 minus 40 into 5, 312.5. That is, we got 0.96, y2 equal to 0.96 meter. Now similarly we are going to take the moment about E. Moment about E equal to 0, that is 0 equal to the, we can go on the right side, it will be easy for us because there is very less amount of the force is acting on the right side. So VB and HB is only acting on the right side, so we can get easily 0 equal to that VB is rotating in the anti-clockwise direction, VB into the distance will be 5. Now HB is rotating in the clockwise, HB into distance will be the y3. There is no extra force is acting on the right side of this E, so only two forces is acting. Now we have to solve this. VB is, we got the VB 40 kilo into 5 plus HB is also we got 312.5 into y3. On calci we got the y3. Y3, if you will left this as it is and this as a right side, then this will go on the division side. So 40 on 40 into 5 divided by 312.5, we got 0.64 meter. After here we got, I think, 0.64 meter. Now as we can see, now we have to find the value of the theta 1, theta 2 and theta 3 and theta 4. As we can see on the figure, on analyzing on the figure, we can find the value of the theta A. For theta 1, it is assumed theta 1 will be equal to tan inverse of y1 by 5. For theta 2, let us see on the right angle triangle, where the right angle triangle is making, here is the right angle triangle making. So for theta 2 we have to take the tan inverse of this distance, this is perpendicular distance to the base, means tan inverse of P by B. Again for theta 3, we can go tan inverse of this distance by this. Okay, I am going to solve now. For theta 1, theta 2, theta 3 and theta 4. Theta 1 will be equal to tan inverse of this is 90 degree, tan inverse of y1 which is given 0.8, I am directly writing, and 5 is given this horizontal distance, which will be equal to tan inverse of 0.8 divided by 5, which will be equal to 0. 9.09 degree. Similarly, theta 2 will be equal to tan inverse of, we can see here, we see on the figure, for this distance only we have to subtract the y2 minus y1, which will be the remaining distance. So y2 minus y1 by horizontal distance is again this 5 will be equal to this 5, that will be the same. So that is tan inverse of y2 is we got 0.96 minus 0.8 divided by 5, we got how much degree on calci. Let's see, tan inverse of 0.96 minus 0.8 divided by 5, 1.83 degree. 1.83 degree. Similarly for theta 3, let's see here on the figure, on analyzing on the figure we can solve this. Theta 3 is this angle, so for this angle we have to take the distance of this, we have to subtract the y2 minus y3, then divided by 5. Tan inverse of y2 minus y3 divided by 5, that is tan inverse of 0.96 minus 0.64 is theta 3, that y3 divided by 5, which will be equal to only 0.64, 3.66 degree. 3.66 degree. Also we got the theta 3. Now we have to find the theta 4. Theta 4, that will be equal to tan inverse of y3, tan inverse of y3 by 5, which will be equal to tan inverse of y3, we got 0.64 divided by 5, that will be equal to 0.64 divided by 5, here we got 7.29 degree. Now we have to find the tension in the different segment. Let us take the tension in this segment as TCA. From C to A, we assume the tension TCA, and here we assume the tension from C to D as a TCD, and from D to C as a TDC. Again on this cable we take the tension as a TDE, from E to D as a TED. Here also same like TEB and TBE. So now we have to find the tension. For that we are applying the Lamine's theorem here, because the three forces are passing from the same point. We can apply the Lamine's theorem and we can easily solve the problems. Now let us take the point C. Here we see the point C is acting, here it is, and here the three forces are acting. One is 40 kilonewton, which is downward direction, and the tension TCD, which is from C to D, and the tensions TCA, which is from C to A. Let us draw this. Now we are applying Lamine's theorem at point A. Here we see that we are going to draw at C this critical reaction, which is 50 kilonewton is given, and this direction from C to D is given. C to D is given TCD. Here from C to A is given us that TCA, and for angle we have to must find the angle. Angle is very important here. So we have to find the angle between the two forces. Here it is given theta 2, and here we get the alternate angle. Since here is theta 1, this also will be the theta 1 due to alternate angle theta 1. Now the angle between this will be equal to, these two forces will be equal to, here it will be the, here we can say this angle will be 180 minus theta 1. If you will do, then this angle will be, and after that we have to add the theta 2. This will be the angle, this one, angle between the TCA and TCD. Now from this will be equal to, this total is 90 degree, only this angle will be 90 minus theta 2. Here we can say this is theta 2, and this only we needed angle between this and this will be the 90 minus theta 2. Also the angle between this will be equal to, this total angle will be equal to 90 plus theta 1. So we are going to apply this Lami's theorem. According to Lami's theorem, the vertical reaction is only given 40 by remaining two forces, angle between the remaining two forces, that is sine 180 minus theta 1 plus theta 2. Also TCA equal to sine 90 minus theta 2. Also 90 minus theta 2. Also TCD will be equal to sine, TCD will be equal to sine 90 plus theta 1. Here now we take the first and second. If you will take the first and second, TCA will be equal to, cross this, multiply, left this one, so it will be equal to 40 into sine 90 minus theta 2 value we are going to write from the above, so 1.83 degree divided by sine 180 minus theta 1. Theta 1 we got 9.09 degree plus theta 2 we got 1.83 degree. So we are going to solve on this, on calci. If we are going to solve 40 into sine 90 minus 1.83 divided by sine 180 minus 9.09 plus 1.83, which will be equal to, TCA will be equal to 316.36 kilonewton. Here we got the tension on the, cable AB, that is TCA, which is equal to TAC, that is 316.36 kilonewton. Now we have to find the tension on the cable TDC. TDC we take the first and last. Here if you will take the first and last, here we take first and second. Here we take first and third. First and third, if you will take, TCD will be equal to 40 into sine 90 plus theta, means plus theta 1 is 9.09 degree. Also sine 180 minus 9.09 degree plus 1.83. If you will if you will 90 plus 9.09, if that is remaining will be the same, and it is coming 312.55. TCD equal to 312.55 kilonewton is tension will be on the cable, tension on the cable CD. Now we got the two tension on the cable AB, AC and CD. Tension on the cable CA 360.36 and also the tension on the cable CD equal to 312.55. Now it is remaining to find the tension on the cable CE and on the tension on the cable EB. So for that, if you will take the Lemming's theorem at point E, then we can get the tension on the both cables on BE and DE. So we are directly going to apply the Lemming's theorem at point E only. So for that, here we can see we are applying the Lemming's theorem at point E. Here we are going to applying the Lemming's theorem at point E, that is tension EB. Here it is the tension TED. The load is 20 kilonewton is acting. Also here is theta 4 and here is theta 3. Now the first thing is we have to find the angle between the two forces. So for that, this angle between the two forces will be equal to the angle between the two forces will be equal to, these two forces will be equal to 180. If you will take this as a 180 and this is not, means theta 4 is minus, on straight line theta 4 is minus and theta 3 if you will add, that will be the angle between these. Now angle between these two forces will be the 90 minus theta 3. Also the angle between these forces will be the 90 plus theta 4. 90 plus theta 4. Here applying again Lemming's theorem, 20 by sine 180 minus theta 4 plus theta 3 equal to TED will be TED, which will be the angle between the remaining two forces, which is 90 plus theta 4 sine 90 plus theta 4. Also will be the equal to TEB, which will be the equal to sine 90 minus theta 3. Now we take the first and second again. Take first and second, that is TED will be equal to 20 into sine 90 plus theta 4. 90 plus theta 4 as we got here 7.29 degree, and also we have the sine 180 minus theta 4 is 7.29 degree plus theta 3 where we got 3.66 degree. 3.66 degree, that will be equal to 20 into sine 90 plus 7.29 divided by sine 180 minus 7.29 plus 3.66, that will be equal to 313.3 337 kilonewton, that is TED. Now if you will take the first and third again, now here we take the first and second we taken, then we got the ED. If you will take the first and third, we will get the remaining ones. Take first and third. TEV will be equal to, similarly 20 into sine 90 minus theta 3. Theta 3, if we have to substitute it, theta 3 is 3.66 degree, and also sine 180 minus 7.29 plus 3.66 degree, that is equal to 20 into sine 90 minus 3.66 sine 180 minus 7.29 plus 3.66. 315.246 kilonewton. If the force is acting this much, TEV will be equal to this much.